Alright, everybody, welcome back. Today I feel like making a game. You guys are welcome to tag along if you like. First thing we need to do, though, is if you want to follow along, you're going to need to download the most recent version of the framework here. I've uploaded it to the forums, or I will have by the time you're watching this, and it'll be labeled as platformer under intermediate lesson 8. I think this is lesson 8, whatever, I've lost count. So yeah, download the zip, and if you look inside you'll see basically it's the framework up until the keyboard stuff that we did, or the what is it, the other thing here, the off-screen surface thing that let us do alpha blending quickly. So that it'll include all that stuff, and it'll also have the fonts and the new animation I made with my tool that I've been kind of chipping away at for the last month or so. So I finally got the tool working, and I can now capture sprites from some kind of source material. And here's one of this is the first thing that I've actually made with my tool. It's just a running guy. It looks pretty good though. It's a nice, smooth 13 frame animation for running. So we'll be using that a little bit later on. So yeah, download this and open up the solution. Let's get started. Just gotta set this up so it's properly in my recording region. And this one goes a little bit up, and this one goes to the right. There. Perfect. Now, you go away now. Okay. So yeah, I made a few enhancements. I cleaned some stuff up. First off, I got rid of all the test junk that was in the game.cpp, so it's pretty much empty again. That's the first thing I did. Second thing I did was I changed the style of the window that we create. I changed it so that, now let me just show you. That's a really freaking big output window. I changed it so that you can no longer resize it. It's no longer resizable, and it cannot be maximized. And that will prevent people from changing the resolution. Because changing the resolution, first of all, it looks like ass, because it's going to be stretching from the DirectX buffer to the window. And it'll just be all like blurry and shit. And secondly, it fucks with the mouse coordinates. Because the game is still working in its native resolution mode, but now your mouse coordinates are going to be based on the window size, so it's not going to match up. If you've ever tried to use the mouse with a resized window, you'll know what I mean. It doesn't work at all. And I mean, there's ways to get around it, but the fact of the matter is you're not supposed to be resizing that shit, so I just removed the option. Just these couple lines here is all I need to do to get that. The second thing I did was I got rid of all the magic numbers, all of the for screen dimensions, so all the things like 800 and this would have been 600 and stuff like that. I deleted all that and replaced it with screen width and screen height, which is defined in here. It's defined here. Just a macro definition. I know, I'm a bad boy. I should be using static constant int, but fuck it. I'm using defines, and if you don't like it, you can go fuck yourself. So yeah, changing these numbers here, like I could change this right now to, I don't know, 1800 by 1600 sounds like a bad idea. Just 1800 by 900. There's a nice resolution. And if I start this, it shouldn't crash. I hope not. I tested this before. Yeah, here it is. It's one big ass window. So, yeah, you can now easily change the resolution of the game to your heart's content. So from now on, we will not be using these values when we're coding our game. We'll be using these symbols here, screen width and screen height. And that way, it'll enable us to change the resolution fairly painlessly if we ever want to. That's the second thing I did. The third thing I changed was in the keyboard. It'll be easier if I look at this one. That's not the keyboard. Here it is. I added a second buffer, a second queue here. And this one holds characters. So the key buffer holds virtual key codes, and the character buffer holds basically ASCII codes of the keys. So you can read from the character buffer or you can read from the key buffer, and you can flush either of them or both of them. And the character buffer and read car and peek car will be very useful for getting actual text input from the user, like if they want them to enter their name or something, because it recognizes shift codes, so you can get uppercase and lowercase, and you can get symbols like the @ sign and whatever, I don't know. When you hit shift, like in any of the number keys, you're going to get symbols, right? And that's good. So yeah, it's still not exactly how I would like it, but it'll work. Probably won't be doing much actual text input for a while in this game, because it's a platformer, right? You don't really type that much in a platformer. So we'll mostly be just using, just reading key states or occasionally checking discrete key presses. But anyways, I did implement that, so I just added this line here to Windows and all the good stuff. So those are the three things that I changed. I deleted a bunch of crap that we didn't need, but I left in some stuff like this bitmap. We're not going to be using bitmap anymore, but I left it in. Well, there's actually no reason to leave this in, but we'll delete it later. But I also left shit in D3D graphics, like what? Well, for example, I left in all this load sprite alpha, load sprite, free sprite. We're not going to be using this. This is the first thing we're going to be implementing in our platformer engine, and that is we're going to be getting rid of these structures like structure sprite, structure font, and stuff like that, and we're going to be replacing them with classes. Actually, font is really fucked up, because font, we didn't even implement, what was it, dynamic memory allocation for font. So it still requires us to have a static buffer on the stack. And that's not cool. So we'll definitely be fixing font when we need to, when we actually want to write some characters on the screen. But for right now, I don't really give a shit about font. What I do give a shit about is Sprite. So we're gonna be basically replacing all this shit here with the good shit. So the first thing we're gonna do is we are going to create a class for surfaces. Up until now, we've basically just, the way we represented a surface was just an array of D3D color values, and we referred to an array of D3D color values as a surface. But now we're actually going to create a surface class, and that class is going to contain the array of D3D color, and it's going to, in the constructor and the destructor, it's going to handle the allocation of that array, or that buffer, or whatever you want to call it, the block of memory that holds the actual pixels. So that's the first good thing, is that we're going to get a constructor and a destructor to handle the memory allocation. Memalloc constructor destructor. Bah. But there's going to be a problem. We're going to have to think of how we want to do this shit. when we draw a surface, basically the surface object is going to have to interact with the graphics object in some meaningful way, because the graphics object holds GFX holds our back buffer, and the surface is going to hold our what do you call this? Just our surface, right? Surf, and we need to get the pixel data from the surface to the back buffer, but these are both going to be private. So we have to figure a way of how do we get these two to interact. And there's a few solutions. There's a few ways we could do it. Syntactically, we could do something like let me just see here. Delete that. So let's say we have something surface surf. This is just a surface object. This is not the same thing as this buffer here. We'll just call this S. Whatever, doesn't matter. Doesn't matter. Surface surf. So we could do something like this. Surf dot draw graphics. This is one kind of syntax we could think of. We pass the graphics object to a draw member that's part of the surface class, and then it draws. We could also do something like graphics dot draw surface, and then we pass it surf. Why do I keep writing it surf? It's surf. There's other ways we could do. We could do something like surf. Now I draw surf. Surf dot draw, and we pass it nothing. We pass it nothing, but in the surface object we could have a graphics pointer to G, and we could make this point to the graphics object. So when you call surface.draw, it uses the graphics pointer to refer to the graphics object. These are the different kinds of syntax that we can imagine for our surface. Now the other thing that we have to really think about is we have to think which class is going to actually be doing the memory transfer, the actual brunt of the work here. Because the class that does the memory transfer is going to have to be able to, it's going to have to know about the internals of both of these objects in order to perform that memory transfer. And it's a difficult problem, trying to think of who has the responsibility to do the actual work when you have two objects interacting with each other. Who is doing the work, and who is having the work done to them? And the way I see it is surface. The data type in surface is basically just your general collection of pixels, and this collection of pixels could work with a bunch of different kinds of graphics backends. I mean, obviously there's a bunch of different ways to do graphics, right? You could do graphics as Direct3D, you could do graphics as OpenGL, as GDI, and no matter which way you do it, your surface is always just going to be a collection of pixels. That won't change. So it's better if the graphics object is the one who does the work. Because that way, if you change this to, let's say, an OpenGL engine or OpenGL graphics object, you don't have to change your surface because it's still just a collection of pixels, right? If we did it the other way, if it was the surface who was doing the work, and then it would have to access the internals of graphics. But if we changed this graphics to OpenGL, the internals would probably change quite a bit, and we'd have to end up changing the surface too. So we have to tie these two objects together, and the way I'm going to do it is graphics is going to know about surface. I'm thinking though, because if instead of having the objects access their private data directly, if I use interfaces, then they don't really have to know about the internals, and it's not so bad, because I could just use put pixel. I could just use put pixel, and in that case Surface wouldn't have to know anything about the internals of graphics. It just has to know the function put pixel, and that's fine. Put pixel is fine for sprite drawing, but if we're drawing a tile, then I wouldn't want to use put pixel. I'd want to use something else. So hard. Well, okay, I've decided, and my decision is this. We're going to use this. We're going to use this syntax here, and the work is going to be done by Surface, and it's going to call put pixel to actually transfer the pixels to the back buffer. Yeah, and that's just the way we'll do it. And if I change my mind later, well, then that's what I do. But for now, this is the way we have it. Now, okay. So I'm going to create a new header file here. I don't think I'm going to bother splitting this class up into a H and a CPP file. So this is surface.h. Add that. Pragma once. And what are we going to include in here? Include D3D graphics.h. Yeah, if I do it this way. What's your problem? What's your problem, brah? Cannot open D3D graphics. Ah, you. No, I'm not changing. I'm not saving any changes to anything. You can suck my dick. Okay, add new item and put it in the fucking correct folder. You cocksucker. Okay, where is it? Here, assets. There it is. It's making me rue the day that I created a separate folder for the source files. Every freaking time. Okay, it was Surface. God damn it. This does not bode well for this. Can I rename this shit? Will this actually rename the file name? Surface. I hope so. Okay. Let's try this again, people. Pragma once. # include. D3D graphics.h. There we go. All right. Now, class surface private. That's not what I wanted. I have to learn what all my crazy braces and everything are on this keyboard again. Okay, so we definitely want a D3D color pointer to surface, and that will be the actual block of memory that holds our pixels. We also want, should I make it unsigned? Yeah, whatever. Unsigned int width, unsigned int height, unsigned, there. So we got our width, we got our height, and we have our the surface itself. I think that's all I really need to start with. We'll be adding other members as the need arises. Public. surface. We create a new surface. And this one will be created from, that's a good thing to think of now. I should probably introduce to you guys the string class. And I don't mean like the C string classes, like string copy and everything. I'm talking about C++, standard template library string, which includes the class string. And yeah, I'm going to do that. Alright. And we'll have a string here. Wait. Yeah, fuck it. std string. All of these classes like Q and everything, they're in the std namespace. So you have to prefix them with std, otherwise you won't be able to access them. And file name. So here's the constructor. Where's my marker? There it is. Surface destructor. Alright, so here's a good start on our skeleton. Now, haven't used string that much in a while, so probably gonna be looking some shit up. But now we have to we're gonna have to look at our sprite and see exactly what do we got. Okay, so yeah, like I said before, we're not using this bitmap routines, these bitmap routines anymore. We're just gonna use GDI plus because it's, I don't know, it's easier, I guess. So load sprite alpha. Yeah, I'll just copy this. Graphics. No, where is it? Surface. There it is. Paste that. So a surface is a little different than a sprite. A sprite will have more information about itself. A surface is just a block of pixels and the dimensions. And perhaps maybe the key, the color, what is it? The key code, the color key, the thing that lets you tell which pixels are transparent. I'm not sure exactly if I'm going to include that yet in Surface, but for now, this is fine. This is good. It's good. Don't worry about it. It's good. We definitely want to get GDI plus in here. Put that there. And we definitely want this library include. Okay, now we don't give a rat's ass about sprite, but we do give a rat's ass about height because it's a member of, you know, our surface. Color key doesn't matter yet. Now the surface, should we use malloc or no? I guess we should use new. We'll use new from now on. It'll make the syntax nicer. I like nice syntax. I'm a fan. Okay, new D3D color array like that. There is no sprite, so we'll just do width times height. And this is surface. There we go. That was easy. Now, here's the part where I gotta do some magic. I mean string manipulation. Okay, so what we want to do is we want to take the file name. Actually, we're going to make this a reference to a string. String do we really need to do anything here? I think not. We'll just do file name. Now I'm kind of getting weirded out here. Because if I... What? You could not find identifier. You cocksucker. Okay. Why can't I get my IntelliSense on this mother? Whatever. File name dot C string. Now I can get my IntelliSense. Okay, yeah. But the problem is that bitmap wants a W char. Does it want a normal character? I'm thinking it only wants wide characters. Now the problem is that I don't think... What's your problem here? Yeah. See, this string here is a it's a character string, but what I need is a W characters. GDI plus is being difficult. I need wide characters. Now there might be a way to... There's a way to make string... Basic string... Yeah, basic string character. What if there's a W string? There is a W string. Sweet. I just guessed and I was right. Okay, so we're gonna use W strings here. Okay, that made my life easier than what I was thinking it would be, and that's good. Easy life is good life. GDI color pixel. I'll just leave this here. Whatevs. Whatevs. Now this is surface, so we'll do that. D3D color A, RGB, get A, get R, get G, get B. Okay. So I think this is basically all we need to do this mother up. What else? What else do I want to do? Nothing? Okay. Next up, we put the destructor into order here. This should be simple, right? Just delete. Yeah, like that, and then surface. So delete that block of memory. And that's it for our constructor and our destructor. Yep. Now, we need to actually draw this mother. So, we go draw. And we go D3D graphics, GFX. Good? Yes. Now, okay, why are you getting all squiggly on me, bro? Alright. Void. There. Now what I want to do is... I think I have some code for this somewhere. Let me just check. Where is our draw sprite? Draw circle, draw sprite. Yes. Where's the thing? Surface. There. Okay. Now what we're gonna do is fix this up a little bit. Actually, it'll be pretty easy. Just delete all the sprite parts here. Yeah, so we don't have a color key yet, so we're not going to do that, but we will do it soon. Okay, x plus x offset, y plus y offset. Alright, x and y are this here. X, right, we need an, should we put the graphics first or last? Put it last. This should technically be unsigned ints, right? Unsigned int. Unsigned int. Blah. Signed. There. But these ones should be ints because they can be negative. They can be off the screen. Draw. X offset. Y offset and graphics. Here we do gfx dot put pixel. There's width. And we don't actually need this, do we? Nope. Oopsie daisies. I should put this here. Alright, because we don't have to check the value of the pixel before we draw it. This is just drawing every pixel in the surface. We'll do a transparent blit afterwards. A blit with color key. Alright. Good. That should be it. And that's it, pretty much. Yeah, that is all she wrote. So, let's try this out, shall we? How do I do that? Well, I could create a surface in game.h. Well, first I gotta include it, don't I? That would be a good idea. Surface.h. And here we go. Surface S. Yeah. And in game.cpp, it's an embedded object, so we have to initialize it here. So we go S, and we got to give it a string. So I'll go W string, and it's a L because it's a wild string. What, doesn't work? What's your problem now? W strings, right. Would also help if I, that doesn't make sense. Because this includes game.h. And game.h includes surface. And surface includes string. So, I know why. Because I did a stupid. I made a stupid. Where's my thing again? What was I looking for? Game.cpp. And I gotta go. Because it's in the std namespace. There we go. And it works. Now we need our path. That's a pain in the ass. I think the name of the dude was Stick Run. Stick Run. Double backslash. Yeah. Double backslash run 0000.bmp. If I am not mistaken. Stick run 0000.bmp. Good. I didn't want to close that, but whatever. So, if we call the constructor with this, we should be able to get a surface loaded in memory with the correct dimensions. Then all we got to do is draw that mother trucker. So we'll just do in compose frame. We'll do s.draw. Let's draw it at 0000 JFX. Okay. Build. Miraculously, there are no syntax errors. However, we also do not get our thing, which kind of sucks. Why you no draw my surface? Okay. That is rather disappointing, but well, we'll figure a way around this. Game dot go to surface. Okay, I don't know what's going wrong here. We'll just put a thingamajig there, and we'll see how it goes. All right. Where is my bitmap? Native image. Result okay. Okay. Where's the width? Height. Damn it. Native image. Brr. Virtual pointer. This is not helpful at all. GDI plus, you can suck my balls. Okay, that did not help me. Anyways, let's keep going. Okay, height. What is height equal to? Auto. 119. That seems about right. Width is 120. Okay, so surface is equal to new d3d color. Height times width. So far so good. What's this? Get pixel. Pixel. ARGB 0. Which is black. Right? That seems wrong because my dude should be mostly white. This seems wrong. Basically, my entire pixel 0. This is very disappointing. Is this all going to be 0? Kind of tired. I'm tired in my soul. Cool. Okay, Yep, it's all black. And that is totally not correct because I don't get it. It's obviously it loaded the image properly because it got the correct width and height. So it found the file. There's nothing wrong with the file name. And yet when it tries to extract the pixels, all it gets is black. Alright, I'm going to try a different image. Because if I'm actually having problems with the bitmaps that are generated by my program. They won't open in some programs like Adobe Photoshop, but they'll open in others. So it could be that the routines from GDI Plus are not able to read the bitmaps generated by my tool. So what we're going to do is we're going to go to here, Chili Projects, and we're going to find a... Where is it? Yeah, whatever. We're just going to find some walking dude here. Copy him. And we're going to go... Where are we going? Debug? No. We want to go to the platformer. Just paste the walking dude in here. Delete this, by the way. You go bye-bye now. And now I'm gonna... you stop debugging. I'm gonna go to game. And I'm gonna go wdude. Please tell me I didn't close that window. Good. wdude00.bmp. Alright. And failed. Good. Let's try debugging this mother again. We'll load that. Load the file name. Width is 80. Height is 50. So that's correct. Now we'll try to get pixel. And this time the pixel actually has decent values. Those look like real proper values for a pixel. So, the moral of the story is that these routines are not, it's not possible for them to load the bitmap generated by my tool. And that sucks balls because how am I going to handle this? Because this is obviously going to be a problem. I could change the way my tool saves the files, but it's just saving it with the .NET framework, so I'm not exactly sure how. The other thing I could do is I could use a program like paint.net or something, and I could use a batch to basically load the files and then save them, and when it does that the format should get all fixed, but that is also kind of a pain in the ass. Oh well, anyways, I'm gonna stop the video right here, and when we come back I will have fixed this problem, which has nothing to do with what we're doing right now, so no sense in doing it on screen. Alright, fixed it. And yeah, it was the file format of my bitmaps for some reason. I don't know what it is, but the fucking .NET framework, when it fucking saves my bitmaps, because I didn't write that code, I just called whatever and it saved those mothers, and it just saves them in a weird fucking way, and fuck the .NET framework, fuck it right in the ass. So I'm gonna have to fix those bitmaps somehow, or fix my program or whatever. But as you can see here, this one I opened up in just normal paint and then saved it, and now it runs fine. So perfect, good, done. That part is done. Now I'm gonna do something here. I'm gonna go to graphics.cpp, and I am going to not go to graphics.cpp. Go to graphics.h, and I'm gonna change the fill value for the back buffer from this to this. I'll change it to 60, which is 60 hexadecimal, by the way. Whatever the hell that is in normal numbers. And now it should be gray. The background should be grayish. Alright, that's good. And we see our sprite here is all the pixels are being drawn. Now what I'm going to do, ladies and gentlemen, is we're gonna create another function here in Surface called void draw transparent, draw keyed. I'll call it draw keyed. And it has the same parameters, except it also has a D3D color key code. Wait, color key. Just key. Just key. Yeah. I was just thinking of something. Just thinking. Just blue sky in it, you know. You know me. Why did I do that? I was still thinking of that other thing I was thinking of. I'm thinking when we compare the color key to the surface value, is there going to be an alpha in there somewhere? And if there is, how will that affect stuff? We'll see. We'll see. Okay, so here we got to do that stuff that we didn't do before, which is D3D color C is equal to this. And then if C is not equal to key, we'll do that. And then here we replace this with C. And that should give us a color keyed thingamajig. Now, we gotta go down to game. And here we do D3D AR. Wait, let's try RGB. I don't think it'll work, but let's try it. XRGB, that's what it was. And I believe it's just 255, 255, 255, right? Because we want white to be the transparent color. Then we do that. And we wait for IntelliSense to stop. Draw keyed. Good. I don't think this is going to work, but let's see. It does work. Okay. So, yeah. And there we have our dude, and he is now properly transparent in the parts that should be transparent. Good times, good times. Here's the problem. Now what I'm going to do is I'm going to add a couple of variables to the game. I'm going to have X and Y. There we go. And in here, I don't want to type shit. Okay, what I want to do, if keyboard dot keys pressed vk underscore up x plus plus. If I can probably do this a lot faster if I do it like that and that and that. Okay, now up, down, fuck you in the eye, left and right. Now up is okay. Obviously that's going to be, this is y plus plus, this is y minus minus, x minus minus, and x plus plus. Okay, so here is our keyboard and stuff, and we do this. And it doesn't work. That sucks. Why? Oh, okay. Well, that would make sense, since I'm not using X and Y to draw my thing. My dude. Let's try that. Now that sounds like a plan. Okay, now the dude moves. I don't know why, but Camtasia is really, I don't know, it's lagging out my system way more than it used to. Kind of pisses me off. Okay, so yeah. Now if I try to move this guy off the screen, we get bad times. Abort. So the next thing we want to implement is clipping. Where's my clipping? I mean my surface. So we need a function here, or well, I guess I can explain this to you guys. Now, up until now, in some of the other parts, like if we remember way back in the day when we drew sprites with a big list of put pixels, the way we implemented clipping was just by having a test for every put pixel. We just test to see whether the pixel is within, like, let's say this is our sprite dude here. That is horrible. What the fuck is that? Okay. Anyways, we test a pixel and we see, is it outside of the screen? And if it isn't, then we don't blit it. So we just run through every single pixel, and if it's outside the screen, we don't draw it. And that's clipping. And that's fine. But it's a waste of time because you end up having to load... Wait. Let me think here. Well, you don't have to load every pixel from the surface, but you do have to loop through and test every single pixel, and it's a waste of time. It's a waste of processor time. Now, what the smart people do is, let's say you've got your surface here and you're going to draw it with these coordinates. What you do is you adjust what you're going to draw. You say, okay, we're just going to ignore this part and we're going to start drawing from here. So we're going to draw from here to here. And we're just going to ignore this altogether. Alright? Or, you can suck my balls. Or if you've got like another sprite over here, you say, okay, well the bottom of this sprite is below the bottom of the screen, so we're not going to draw this part. This part is out of the question. And the left side is less than the left side of the screen, so we're not going to draw this part. And we only actually go through and draw this part. That's how the smart people do clipping on sprites. So that's how we're going to do it, because we are smart. We're smart like that. And the way we do it is we just we make some comparisons here. So how am I going to do this? Wait, we want signed or unsigned? We want signed. We want int. We want constant int y start. So this is the start coordinate. Let me think here. Because we got two different coordinate spaces that we're working with, and we don't want to get them confused. We've got our, like let's say we're drawing this sprite, or whatever you want to call it. So we got our surface here, which is 0, 0 here. This is 0, 0. And this is our surface space. But then we've got our screen space. And in screen space, this is 0, 0 here. So we got to think of what our variables are representing and how we want to do stuff. And yeah. And what I am thinking is, well, this x and y here, they represent surface space. And then we add our offset to get the screen space. So our x start and our y start should be our starting points in surface space. So we go x start. Now we have to calculate where on our surface we want to start. Normally we start at 0, but if our where's my frickin' thing? Here, if our surface is a part of it is above the top of the screen, then we're not going to start at 0, 0 on our surface. We're going to start somewhere below that. So we got to figure out this offset of where to start. And how we do that is I just basically pull it out of my ass. Now it's going to be it's going to have to do with y offset. Should be negative y offset, right? If you think about it, 0 minus y offset. Because, let me just go here. So imagine a sprite that's flush with the top of the screen. So y offset is equal to 0, and we have to start at y coordinate 0 when we're drawing it, because we want to start at the very top. It's right flush with the top. Now if we start with another surface, and let's say that one is y offset is equal to -1. right? So it's not flush with the top of the screen, it's actually one above the top of the screen. And in that case, we want to start with row, is it row? Yeah, row 1, right? Because row 1 will be the row that's flush with the top of the screen. Row 0 is already off the screen. So we want, if our offset is -1, we start with row 1. If our offset is -2, here, -2, then we start with row 2. So, by that reasoning, y start is equal to basically the negation of y offset. Constant int x start will be the same deal, -x offset. Now, y end is equal to, this one will be a little more trickier. So for example, with this one, y end is down here. So this would be 0. This one would be height -1. This is in surface space. So in screen space, this would be, I can't write with this. Fucking mouse, man. Fucking bane of my existence. Alright. So in surface space, this is 0, and this is height -1. And in screen space, this is y offset. Yeah. And this is y offset plus height -1. Alright. So we want to take the amount that it's overlapping. The bottom pixel here is going to be screen height -1. So we take screen height -1 and we subtract that from y off plus h -1. And that's how much we're hanging off the end. And so that's how much we have to subtract from the height. So we take height minus this value. This is just the overhang. We subtract that from the height, and that will give us our end position. End point. Yeah, that makes sense. Now these -1 minus -1, they'll just cancel out. So we get y offset plus height minus screen height. And then we're subtracting that from height. So h minus y off plus height. And subtracting a negative means we're adding screen height. Now, wait. Subtract minus y offset. Subtract a positive. Subtracting height from here. Alright, so here we got height minus height. So our end should be y offset plus screen height. Wait, negative y offset plus screen height. So screen height minus y offset. That makes sense, because if you think about it, our other one was just negative y offset for this part here. And now we're getting screen height minus y offset. So there's a nice symmetry in that. So y end is equal to screen height minus y off, and constant int x end is equal to screen width minus x off. Alright, so now we have our start points and our end points. So x is equal to, y is equal to y start, as long as y is less than y end. X is equal to x start, as long as x is less than x end. And this should just stay the same, because we're just taking those surface coordinates and we're translating them by the screen position. Yeah. And I gotta do the same thing for over here. So copy that, paste it. Ugh. I don't know why I got tabs in there. And I can probably just get away with doing this and this. Beautiful. All right. Make sure nothing went wrong, horribly wrong. Yeah, signed, unsigned mismatch. Okay, what's your problem here? Unsigned int y end. Yeah, these can all be unsigned because they are in what am I calling it again? Surface space. Surface space doesn't recognize negative numbers. Build. No. What's your problem, brah? Ah, okay. You don't want to feel left out. I can understand that. Okay. Now, this should clip our shit to the screen. Or it should crash the program. Either way is good. I'm good with either. You know, wait a minute. Okay. Yeah. There's one little problem with my logic here, a little flaw in my reasoning. And that is so much work. I don't want to do work. I am allergic. If I'm not going to put if statements. I'm going to do stuff here. So what I want here is I want the maximum. You see, I wrote this line here, the calculation of y start, assuming I made the assumption that the sprite or whatever is going to be off the screen. So its y offset is going to be negative something, right? And then when you invert that, you'll get a y offset that's somewhere in here. But what if your sprite is in a normal position on the screen? Then what happens? Well, your y offset is a positive number. It's going to be positive something. And when you invert that, you're going to get a negative value for your start, which will put you somewhere over here. And if your numbers are unsigned, then that'll just fuck you up hardcore, because unsigned, you try to store a negative number in an unsigned, you're just going to get fucked up. So, the moral of the story is we have to check to see whether, first of all, whether we are off the screen or not. And we can do that very neatly by just doing a maximum. So if we negate our y offset, and wait, did I say maximum? Because I meant maximum. If we negate our y offset and we get a positive number, that means our y offset was originally negative and we were off the screen. And then we're going to take that positive number and store it into y start. But if we negate our y offset and we get a negative number, that means y offset was originally positive and it wasn't off the top of the screen. And so in that case, we want to use 0. We want to start at 0, which is at the very top of our sprite or our surface. So what max does is it takes these two values and it gives us the biggest one. So if y offset turns out to be negative, we'll just get 0. But if y offset is a positive number, we'll get that. And that's the magic of max. And I don't even know, but I'm not sure, but I think this might not be a standard C thing. What part of the C library? I think this might be Microsoft specific, or anyways, it's not part of the standard, so just letting you know. I'm not actually sure myself. If you look at it, you can see it's just a macro that uses a tertiary expression or whatever. Fuck, I don't know. Whatever. Now this one we use min. Same idea though. It's either going to be minus y offset. Yeah, so we're going to start here, but if this goes below the extent of our so if this expression here, again, it's created assuming that our ass is hanging off the bottom of the screen. But if our ass isn't hanging off the bottom of the screen, our endpoint is going to end up way below the sprite, and that's not good. So what we do is we take the minimum of either. We take the minimum of this calculated endpoint and the very bottom of the sprite, which is just height. So we're either going to be height or we're going to be the calculated clipping point. And we take the smallest of those two. The logic is the same as what I showed you above. It's just in the other direction, I guess. Now doing this, we should be good to go. I'm going to put this one here too. But who knows, that could be, my logic could be completely flawed here. Signed unsigned mismatch. Yeah, that can't be helped, brah. I mean, I guess I could make this thing signed, but actually, no. Nah, it's good. We're solid. Let me just make sure this is proper. Yeah, it's fine. I don't like warnings that piss me off. So I'm going to do this. I'm going to cast this to unsigned. Because the way we wrote it here, these, well, it's kind of complicated. I won't lie to you. It's kind of complicated. Alright, so we can move. Here we are. Now let's try to get clipped. Yeah, we're clipping like a mofro. Look at us clip. It's like a freaking sheep shearing competition, I'm telling you. Now, I think probably if we go completely off the screen, it'll just crash. God damn it, I wonder why Camtasia is lagging me down so bad. Let's go off the screen. Okay, we're not crashing. That's interesting. That's very interesting. Just go really far off the screen. Way off the bottom. So I guess the way the logic works is that if we go completely off the screen, it just... Wow! That scared me. That actually scared the shit out of me. I don't know why. Okay, so yeah, clipping is not perfect yet. Because if we go off the screen completely, we're still fucked. There's a couple of ways I can think of solving this. if I give up on the idea of making these unsigned, I think that'll solve my problem right there. Ugh, I gotta do this one too. Because what'll happen is the loop will end up such that if it's completely off the screen, y start will already not satisfy the condition of less than y end, or x start will not satisfy the condition of less than x end, and it just won't enter the loop. So it'll just skip the loop and be done with it. The other way I could do this is I could just create a test at the very beginning, checking to see if we're completely off the screen. And if we are completely off the screen, we just skip everything. But, you know what? Fuck it. I'm just going to make it work with the current loop situation. And there is a case where there's a little bit of inefficiency, but it's not a big deal. It's not a big deal. And there's also, now I wish I didn't put all these unsigned ints in. You know what? There's someone moving in the apartment beside me, and they're really loud. That sucks. Alright. Still don't like me, do you? I don't know what your problem is. Probably this thing here, unsigned. And this one's signed. But you know what? You can go fuck it. You can go fuck yourself. I don't care. I can make that an int later on. I could cast it to an int right now. Fuck it. I don't want to do it. I'm gonna let my OCD take a ride this time. That's not even a real expression. I'm just talking crazy. Don't scare me. Bah! It scared me a little bit. So that didn't work. That did not work. All right. Why didn't that work? Well, there's only one way to find out. To do the exact same thing I've been doing. I'm more interested in learning why my computer is lagging with Camtasia on, but whatever. Okay. We go retry. Break. Where's my call stack? Step out here. Step out here. Okay. X is 88 locals. X end, Y end. Yeah, that makes sense. X end is at the end of the sprite. X start, Y start is at 0. Now that makes absolutely no sense. Oh no, it does. But then X, Y end, X end should be a small number because we're past the bottom of the screen. Number should get smaller, right? Screen height minus Y off. Y offset is... Maybe it's Y off minus screen height? Does that make sense? Y off minus screen height. That doesn't explain why my clipping works though. Alright. Maybe I have to convert this to int. I'm just like totally grasping at straws right now because I don't want to actually have to work it out. I don't want to have to think. I shouldn't be forced to do that kind of stuff. It's beneath me. Right, so when Y offset gets larger and larger, this value is going to get tiny. Right. then it's going to be compared to this one. I think casting this to an int is a good idea. I'm going to go with that. And start with debugging. Probably won't work, but it's worth a try, right? Come on, clipping. Let's clip it up. That's gonna scare me. Oh, it worked. Sweet. I was totally expecting that. I knew it was gonna work all the time. It looks like our clipping function is off by 1 because I can see a little bit of gray at the very bottom. Let me see. Yeah. Like there's 1 pixel that it clips it and it's like, yeah, we're not going to draw that last pixel. Wait. Yeah. That's not good. So we got a little off by 1 error there. Probably on the right side too, right? Yep, off by 1. I want to make sure that the right side also doesn't. Good. Okay. So, let's check the left side and the top and see if it is also off by 1. Because I don't think the left and the top are off by 1. I think they're fine. Nope, they're also off by 1. Okay, now I think I might be going crazy. That grayness might actually be the border of the non-client area of the window. Now I can't tell. I think this gray color is kind of fucking me up. So I'm going to change it to white. Where's the thing? Where's the thing that I can... There it is. F. Alright. Do it up. Yeah, signed unsigned mismatch. Okay, so that is definitely not a problem. Let's try the bottom. Nope, we're not off by 1. It was just the grayness of the background. It is the same color as this border here. So it looked like I was clipping a little bit too much. I was a little overzealous in my clipping, but nope. My logic was perfect. Okay, so now we have functions to draw opaque and transparent surfaces, to copy them to the back buffer and copy them clipped. So yeah, and that is most of the work that is needed when you're going to be drawing a sprite. And I'm feeling a little pooped now. I think I've done enough for this episode. So, next episode, I guess we will create a sprite class based on, it'll include a surface. It'll include a reference or a pointer to a surface. And I don't know if it's going to be, I guess it will be animated. So, yeah, tomorrow we'll do animated sprite. Or not tomorrow, but next lesson. Using our surface. And we can see the running dude in action. It's actually pretty good. It's a pretty nice animation. If I can get the fucker to load properly. So I'll have to ah, shit. I think what I'll probably do is I'll open these files and save them in Paint. That way, when you guys download them, you'll download the non-fucked up versions of these bitmaps. So I am going to first unfuck up these bitmaps, and then I'll I'll re-add them to the zip file before I upload it. Yeah, there's no point, there's no reason for you guys to have to upload my fucked up zip file. That's interesting. This one is opaque, but this one looks transparent actually. Look, see how this, you can see the blue here, but here it's not blue. This is the one I opened up and saved again. So, yeah, I don't know. Whatevs. Who the fuck cares? So I'll fix these, I'll upload shit, and next lesson we will we'll redo the animated sprite, but this time with a proper class. We'll make it all classy-like. Alright, so until then, keep your stick on the ice or whatever. Later.